Thousands of years before telescopes or written language, our ancestors built observatories from stone. This video reveals 20 prehistoric sites that mapped the heavens with incredible accuracy. By the end, you will see how ancient cultures across the globe independently unlocked the secrets of the solar system. How did builders without modern tools align massive stones to catch a single ray of sun? Why would societies spend generations erecting monuments to track the stars? These structures are far more than ancient ruins. They are humanity's first complex scientific instruments, encoding celestial knowledge into the very landscape. Their silent stones hold stories of solstices, eclipse predictions, and lives perfectly timed to cosmic cycles. What does our shared drive to understand the sky tell us about being human? That profound shift in human life, from following herds to tending fields, changed our relationship with the sky forever. A successful harvest meant the difference between survival and hardship, and the only reliable calendar hung above them in the motion of the sun, moon, and stars. This was a matter of absolute necessity. Knowing precisely when the last frost would end or the autumn rains would begin was not philosophical curiosity. It was the foundation of their entire world. So they began to watch with a patience we can scarcely comprehend today. They noticed that the sun did not rise in the same place each day. Over the course of a year, its rising point would travel along the horizon, northward until it seemed to pause at the height of summer, then southward to a farthest point in the depth of winter. These two pauses, the solstices, became the anchors of their year. The earliest observatories were not buildings at all, but chosen features of the land itself. A distant notch between two hills might perfectly frame the rising sun on the longest day. A single, deliberately placed standing stone could cast a long shadow that touched a specific point only at dawn on the winter solstice. These were the first experiments in monumental timekeeping, simple yet brilliant acts of observation made permanent. Over generations, this knowledge deepened and became more sophisticated. What began with a solitary stone grew into rings of towering megaliths, into precisely aligned corridors and window-like apertures built from tons of rock. The architecture itself became the language. The alignment was the instruction. A builder could pass on a complex understanding of an 18.6-year lunar cycle, not by writing it down, but by designing a structure where the moon's light would behave in a predictable, repeating pattern for centuries. This drive to encode cosmic order into stone appears independently across continents and cultures, from the windswept plains of northern Europe to the high deserts of the Americas. It speaks to a universal human trait, a shared need to find rhythm in the chaos, to mark our place within the vast turning of the heavens. This foundational impulse, born from the soil and the seasons, is what we see etched into every one of the 20 sites we are about to explore. The silence of the Salisbury Plain is a modern illusion. 4,500 years ago, this landscape would have echoed with the sounds of a monumental undertaking. Communities, driven by a shared vision that spanned lifetimes, orchestrated the movement of colossal bluestones from mountains over 150 miles away. Each stone, weighing many tons, was a testament to a society capable of staggering coordination and long-term purpose. The result was Stonehenge, an icon so familiar we risk forgetting how utterly mysterious it remains. Its primary axis is a perfect line to the midsummer sunrise and the midwinter sunset. On the longest day, the sun's first gleam would crest the horizon and shine directly through the monument's heart, framed by the great central arch. The outlying heel stone acts as a permanent marker for this celestial event, a sentinel waiting for that single, brilliant moment each year, but the alignments go far deeper than the sun. Recent studies of the ring of pits known as the Aubrey holes suggest they could have been used as a predictive calendar for lunar eclipses, those dramatic moments when the Earth's shadow falls across the moon. Even more remarkably, the so-called station stones align with the major lunar standstill, an extreme point in the moon's orbit that only occurs once every 18.6 years. To encode that cycle into architecture means observers had to track the moon's subtle dance for decades, passing that precise knowledge down through generations of builders. This transforms our understanding of the site. Stonehenge was not merely a ritual space, it was a sophisticated astronomical computer built from sarsen and bluestone. Its construction was a multi-generational project that required centuries of collected observational data, a physical library of celestial patterns. The sheer effort implies a highly organized society with a deep, sacred connection to the sky, a connection we will find echoed in remarkable ways as we journey to our next observatory. A similar obsession with the winter sun's return is carved into the green hills of Ireland's Boyne Valley. Here, a massive circular mound known as Newgrange rises from the landscape, a structure older than Stonehenge and the Great Pyramids of Giza. From the outside, it appears as a great grassy hill, but its true purpose is hidden within. A single, narrow passage stretches 19 meters into the heart of the mound, ending in a cross-shaped chamber. For most of the year, this inner sanctum lies in absolute darkness, but for a few precious days around the winter solstice, something extraordinary happens. At dawn, as the sun crests the horizon, a slender beam of light pierces a specially designed opening above the entrance, a feature archaeologists call a roof box. This shaft of golden light travels straight down the long passageway, slowly illuminating the central chamber in a dramatic display that lasts for roughly 17 minutes before fading away. This was not a happy accident. The builders engineered this entire structure, this artificial hill of 200,000 tons of stone and earth, with one celestial event in mind. They oriented the entrance with meticulous care, calculating the sun's lowest, most southern rising point of the year. The roof box itself is a masterpiece of precision, a stone-framed window that filters and directs the light. To achieve this, the Neolithic builders needed more than just astronomical knowledge. They required advanced engineering to ensure the heavy mound would not settle and shift the alignment over centuries. They succeeded so completely that this phenomenon still occurs uninterrupted after more than 5,000 years. The symbolism is profound and deeply moving. At the darkest time of the year, when the sun seems weakest and the world cold, this architecture orchestrates a moment of literal illumination deep within a resting place. For a culture that saw no firm separation between the cycles of nature and the journey of the individual, this was a powerful ritual of renewal. The returning sun, conquering the darkness to reach the inner chamber, represented the enduring promise of life and continuity. Newgrange is a monument to hope engineered in stone, a deliberate, breathtaking fusion of cosmic observation, mortal remembrance, and a steadfast belief in the return of the light. This architectural language, speaking of solstices and the spirit, would find a stunning parallel far across the Atlantic Ocean. The architecture of light at Newgrange was an act of profound belief, but the earliest sky watchers began with something far more practical. In a field in central Germany, the oldest known solar observatory in Europe reveals a community taking its first, deliberate steps to measure the year. The Goseck circle was unknown to modern eyes until 1991, when an aerial survey revealed its ghostly outline in a wheat field. This was not a monument of stone, but of earth and timber, built around 4,900 BCE. It consists of a simple circular ditch and bank with two concentric rings of wooden posts inside. What makes it extraordinary are its three gates, positioned at precise points around the circle. On the winter solstice, an observer standing at the center would see the sun rise through the southeastern gate and hours later set through the southwestern gate. The alignment is so exact that the rising sun would have filled the entire gate with light. The same precision marked the summer solstice sunrise and sunset through the northeastern gate. Here was a complete, functioning solar calendar carved into the landscape. Its design is deceptively simple, using wooden posts as sightlines against the open horizon. This was astronomy made accessible, a tool built by and for an entire community to mark the critical turning points of the year for planting and harvest. The Goseck circle was not alone. Dozens of similar circular enclosures, often called rondels, have been found across Central Europe from this same era. This suggests a widespread cultural tradition, a shared knowledge of solar geometry that connected distant Neolithic villages. They were gathering places, likely used for ceremonies that coincided with these solar events, blending practical timekeeping with social and spiritual life. The genius of Goseck lies in its elegant clarity. It represents the moment astronomical observation transitioned from noting a single hilltop notch to constructing a permanent geometric instrument for measurement. It provided a reliable communal reference point, a shared truth written in sunrise light. This foundational step, mastering the solar year with posts and ditches, would give communities the confidence and the need to embark on projects of far greater ambition, projects that demanded not just wood, but the enduring permanence of stone. The sophistication of Goseck's solar calendar is undeniable, but a temple complex on a Mediterranean island would elevate this celestial architecture to an art form. On the rugged southern coast of Malta, the Mnajdra temples stand as a silent testament to a culture of profound astronomical insight. Built by a mysterious prehistoric society around 3600 BCE, these structures are among the oldest freestanding stone buildings in the world, predating even the pyramids. Their true genius, however, is not just in their age, but in how they choreograph light with breathtaking precision. The lower temple at Mnajdra is a masterclass in solar alignment. Its main doorway is not just an entrance, it is a calibrated instrument. During the spring and autumn equinoxes, when day and night are of equal length, the rising sun's rays pass straight through this doorway. They travel across the interior to project a perfect, brilliant rectangle of light onto a central megalith deep within the sanctuary. It is as if the sun itself is invited to mark a specific spot at these two balanced moments of the year. But the builders did not stop there. At the summer and winter solstices, the sun's angle changes. On these days, the sunlight does not flood through the center of the door. Instead, it precisely illuminates the outer edges of the large stone slabs that flank the doorway. This creates sharp, clean lines of light and shadow that act as a natural calendar, demarcating the sun's farthest travels to the north and south. To achieve this, the Neolithic Maltese builders had to shape and position massive blocks of local limestone with incredible care. Each stone's placement was a deliberate act based on generations of watching the horizon. This indicates a prolonged, dedicated period of celestial study, a deep-seated cultural knowledge encoded directly into the architecture. The purpose was likely to regulate a complex ritual calendar, tying agricultural cycles and community ceremonies to these four cardinal points of the solar year. Mnajdra is not a simple observatory, it is a temple where the cosmos itself performed the ritual. The sunlight became the high priest, illuminating the sacred space according to a divine, predictable schedule. This seamless fusion of spiritual belief, architectural skill, and precise astronomy shows a society thinking on a grand, cyclical scale. They saw their world not as random, but as an orderly part of a much larger celestial mechanism, a perspective that would be built to an even greater scale thousands of miles away in the deserts of the American Southwest. The precision of Mnajdra's solar theater was born from a temple's sacred walls. but another culture would build its calendar directly onto the horizon itself. On a barren ridge in the coastal desert of Peru, 13 stone towers stand in a silent, orderly line. This is Chankillo, a fortress complex built around 2,300 years ago by a mysterious pre-Inca society. From a distance, the towers resemble the decaying teeth of some giant stone jawbone, but their true purpose is revealed only from two specific vantage points. To the west and east of the ridge, ancient observers built simple, walled viewing platforms. From these precise spots, the entire skyline transforms into a colossal measuring device. Throughout the year, the sun does not rise over a natural mountain range here, but over this man-made horizon. As the Earth orbits, the sun's rising and setting point shifts north and south along the crest of the towers. Each tower corresponds to a specific date. On the December solstice, the sun rises directly over the southernmost tower. Over the following weeks and months, the sunrise point marches steadily northward along the line, tower by tower, until it reaches the northernmost tower for the June solstice, before beginning its journey back again. The accuracy is stunning, allowing observers to pinpoint any day of the year within a margin of just 1 or 2 days, simply by watching which tower was crowned with dawn's first light. This was a solar calendar of breathtaking simplicity and genius. Unlike Stonehenge or Newgrange, Chankillo lacks obvious ceremonial grandeur. Its design is starkly functional, a tool first and foremost. It speaks of a society that needed to know, with bureaucratic certainty, the exact date. This knowledge would have been vital for managing agriculture in a harsh desert environment, for coordinating seasonal fishing, and for scheduling trade and ceremonial gatherings across a wide region. Chankillo stands as powerful proof that the drive to measure the sky with exactitude was not confined to Europe or the Mediterranean. Here, on a different continent, a culture independently arrived at a monumental, yet elegantly straightforward, solution to the same fundamental problem, turning a barren ridge into a permanent stone calendar for an entire civilization. This practical mastery of the solar cycle, however, was just one piece of a much larger puzzle. To truly understand their world, ancient astronomers knew they had to solve a far more elusive and complex mystery: the wandering dance of the planets. The planets moved to a rhythm far more complex than the sun's steady march, a challenge that would require a different kind of observatory. But before we trace those wandering lights, we must first understand how a culture could master the entire sky without building a single permanent wall. High on a remote plateau in the Big Horn Mountains of Wyoming, a simple stone pattern speaks to this profound flexibility. The Big Horn Medicine Wheel is a perfect circle of limestone rocks, roughly 80 feet across, with a central cairn connected by 28 spokes to an outer ring. To a casual glance, it might seem like a mysterious but basic design left on the ground. Its true purpose, however, is written in the horizon it commands. From this high vantage point, the entire sky is a dome, and the wheel acts as a permanent set of sightlines. Key alignments between cairns at the wheel's rim point precisely to the summer solstice sunrise and sunset. But the genius of the design goes far beyond the sun. Other spokes align with the heliacal risings of specific, brilliant stars: Aldebaran, Rigel, and Sirius. A heliacal rising is that first, brief reappearance of a star just before dawn after a period of being lost in the sun's glare. For nomadic plains cultures, these celestial events were not just markers, they were urgent signals. The rising of Sirius, for instance, might coincide with the peak of summer heat or signal the time to begin a journey to lower elevations. This wheel integrated solar, lunar, and stellar cycles into one elegant, open-air instrument. Its construction required no quarrying or lifting of megaliths, just the careful, knowledgeable placement of stones gathered from the surrounding plain. This is a crucial reminder that an observatory does not require a towering monument. It can be a pattern, a relationship between the observer, the land, and the sky. The wheel's simplicity allowed it to serve generations of people who lived in motion, a stable, sacred reference point in a life of seasonal migration. It represents a portable astronomy made permanent in location, not in structure, a testament to the universal human need to find order in the cosmos, regardless of how one lives upon the earth. This connection between the heavens and the rhythm of life on the move finds a stunning parallel across the Atlantic, where another culture would use the very earth itself to track a cycle of time so long it defies simple human memory. The open, flexible astronomy of the medicine wheel stands in stark contrast to a monument of overwhelming, rigid order. On the windswept coast of Brittany, France, the Carnac alignments present a sight that defies easy explanation. Over 3,000 standing stones, some towering nearly 4 meters high, are arranged in astonishingly straight, parallel rows that stretch for kilometers across the countryside. Walking among these silent, grey sentinels feels like navigating a petrified army frozen in time, while their original purpose remains one of prehistory's great enigmas. A compelling theory suggests this vast complex was not built for the sun, but for the moon. The sheer, staggering scale of Carnac hints at a societal obsession with a celestial body whose rhythms are far more subtle and complex than the sun's annual journey. Unlike a solstice, which happens at the same 2 points each year, the moon's behavior is a long, slow dance. Its rising and setting points along the horizon shift within a much wider arc over an 18.6-year cycle, reaching extremes known as the major and minor lunar standstills. To track this, you would need not 1 or 2 sighting stones, but an entire grid of reference points. The endless rows at Carnac may have provided exactly that, a permanent, graduated scale etched into the landscape against which the moon's shifting position could be measured with precision year after year, decade after decade. This was not a monument for marking a single day, but for mapping a generational cycle. The knowledge gained would have been profoundly practical for a coastal people. The moon governs the tides, and understanding its most extreme phases could predict exceptionally high or low waters, vital information for fishing, gathering shellfish, or even coastal travel. It may also have structured a ritual calendar of far greater complexity than a simple solar year, tying ceremonies to this longer, more mysterious rhythm. Carnac represents a different kind of astronomical ambition, one focused on patience, long-term recording, and the intricate patterns of the night. It shows us that prehistoric curiosity was not satisfied with just the sun's reliable clock, but was drawn deeply into the more elusive silver mechanics of the moon. This fascination with weaving together the cycles of both great lights in the sky would find its ultimate expression in a place where architecture itself became a perfect model of the cosmos. The lunar obsession of Carnac required a landscape reshaped by human hands, but the next observatory reveals a different kind of genius, one that worked in harmony with the Earth's own architecture. High on a volcanic hill in North Macedonia, the Bronze Age site of Kokino feels less like a construction and more like a discovery. At an altitude of 1,000 meters, the wind sweeps across a plateau of weathered volcanic rock, offering a 360-degree view of the distant horizon. Here, around 1,800 BC, ancient sky watchers did not erect towering megaliths. Instead, they looked closely at the natural throne the mountain had already provided. They identified specific, sharp notches in the rock formations along the ridge, natural features that perfectly framed key points on the horizon. Then, with remarkable economy, they enhanced what nature had given. They placed simple stone markers on the flat platforms below these notches, creating precise sightlines. An observer sitting on a particular carved stone throne would watch the sun rise directly through a specific rocky cleft on the summer solstice. On the winter solstice, the dawn would appear through a different, carefully chosen notch. The same precise alignments marked the equinoxes, those moments of perfect balance between day and night. But Kokino's purpose may have extended beyond the sun. Other, smaller markers are positioned in a way that suggests they tracked the moon's more complex journey, perhaps noting its standstill positions. This was astronomy of elegant simplicity. The mountain itself was the primary instrument, a permanent, stable platform with a perfect horizon. The human contribution was the act of recognition and subtle calibration, turning a beautiful landscape into a precise, functioning calendar. The elevated location was not just for the view, it lifted the observers above the mundane world, closer to the celestial realm they were studying. In this thin air, Kokino likely served a dual purpose. It was a sacred place where rituals could be timed to the sun's pivotal moments, but it was also an open-air classroom. The clear, consistent alignments made it an ideal tool for teaching the next generation of priests or elders how to read the sky, passing down a critical body of knowledge without written words. Kokino stands as a powerful testament to the principle of working with the land, not just upon it. It shows us that the first step in building an observatory was often careful observation of the site itself, finding the celestial patterns already written in the stones and simply adding a human footnote. This respectful dialogue between nature and knowledge would reach a breathtaking scale in a desert canyon, where an entire civilization would align its greatest buildings to the cosmos. Venus was more than a star to the Maya. It was a divine actor whose movements dictated the fate of kings and kingdoms. In the ancient city of Uxmal, they built a stage for its most dramatic entrance. The governor's palace stretches across an artificial platform, its long, low facade decorated with thousands of intricate stone mosaics. Its architectural beauty is undeniable, but its true purpose is revealed not by looking at it, but by standing upon it and looking out. The entire building is skewed at a deliberate, precise angle from the city's main grid. This was not a construction error, but a calculated alignment to the distant horizon. From a specific point on the palace, an observer would witness an event that occurs only once every 8 years. On that morning, the planet Venus, at its southernmost rising point in its complex cycle, would crest the horizon directly over the peak of a faraway pyramid. Imagine the scene, a ruler or priest standing in that appointed spot, watching the brilliant morning star, a deity they called Noek, the great star, appear exactly where prophecy and architecture said it would. This was celestial governance in stone. The Maya did not just watch Venus, they mastered its rhythm. They calculated its synodic cycle, the time it takes to return to the same position relative to the Sun and Earth, as 584 days. They knew that 5 of these Venus cycles equaled almost exactly 8 solar years. This 8-year alignment at Uxmal was a physical monument to that hard-won astronomical knowledge, a way of locking their sacred calendar into the very orientation of a royal palace. The carvings on the facade reinforce this message, with geometric patterns and symbols scholars believe represent celestial bodies and cosmic order. For the Maya, Venus was intimately linked with conflict and the legitimacy of rulers. Its predictable reappearances could be interpreted as omens, guiding the timing of military campaigns or royal ceremonies. By building a palace that literally framed Venus's most extreme rising, the lords of Uxmal were demonstrating their privileged connection to the cosmos itself, asserting that their authority was written in the movements of the gods. This fusion of power, prophecy, and precise astronomy shows a civilization thinking in cycles of time far beyond the simple solar year, a sophistication we will see echoed in another Mesoamerican metropolis obsessed with tracking the sun's most perilous day. The Maya built their palace for the wandering star Venus, but high in the Andes, an entire empire was built for the sun itself. Perched on a ridge between soaring peaks, the Inca citadel of Machu Picchu feels like a place suspended between earth and sky. Within this stone city, one structure captures their celestial devotion with perfect clarity, the Torreon, or Sun Temple. This semicircular tower, built with the flawless masonry the Incas are famed for, encloses a natural outcrop of living rock. The builders did not level this stone, they embraced it, carving its surface into a smooth, sacred altar. Above this altar, a trapezoidal window is cut with meticulous precision into the tower's wall. Its purpose is revealed only on the morning of the June solstice, the shortest day of the year in the southern hemisphere. As the sun crests the distant mountains, a single, powerful beam of light pierces this window. It falls directly upon the ceremonial altar, illuminating the carved stone in a dramatic pool of gold. This was no accident of architecture, it was the entire point. For the Incas, the sun was Inti, the divine ancestor and life-giver to whom the emperor himself was directly linked. The solstice marked Inti's moment of weakest strength, a time of cosmic vulnerability that required powerful rituals to ensure his return, and with him the renewal of the world. The sunlight touching that specific stone was likely the signal for ceremonies of offering and affirmation, a direct physical communion between the divine and the imperial order. What makes Machu Picchu's observatory so profound is its philosophy of integration. The Incas were master engineers who moved mountains, yet here they chose not to dominate the landscape, but to collaborate with it. The altar is the mountain itself, the window a human-made aperture, the sun the activating force. This seamless blend reflects the Inca concept of a living, sacred geography where celestial patterns, earthly features, and human constructions were all threads in the same fabric. Their empire, connected by a vast network of roads and aligned administrative centers, was itself a macro-scale reflection of this ordered cosmos. By reading the sun's light on their altars, they were not just marking time, they were maintaining the balance of the universe, a responsibility etched into the very stones of their most sacred retreat. Yet the permanence of stone and mountain can obscure a vital truth about these ancient sciences. For some cultures, the observatory was not a monument meant to last forever, but a living instrument, one that required care and renewal with each passing generation. In the fertile floodplain of the Mississippi River, near present-day St. Louis, the great city of Cahokia thrived around 1000 CE. At its heart, amidst enormous earthen mounds, its people built their celestial clock not from granite but from cedar. Archaeologists call these structures the Cahokia Woodhenges, a series of large, precise circles made from massive wooden posts. The largest of these circles used 48 towering posts, each carefully placed to create a perfect horizon inside the city itself. From a central observation post, the sightlines were meticulously arranged. On the equinoxes, the rising sun would appear directly over a specific post, marking the day of balance. On the solstices, the dawn would be framed by different posts anchoring the solar year. This wooden ring was a functioning communal calendar, but wood, unlike stone, decays. A post that rotted or was damaged had to be replaced, and the archaeological record shows the entire circle was rebuilt several times over the centuries in slightly different locations. This is the crucial insight. The Woodhenge was not a one-time construction to be left for the ages. It was a maintained instrument, a practice. Its existence required an unbroken chain of knowledge, a living tradition where elders taught the next generation exactly how to align the new posts to preserve the sacred alignments. This was sky watching as an active community responsibility, woven into the annual rhythm of life. The 48 posts of the largest circle hint at even deeper knowledge. They may have tracked subdivisions of the solar year, creating a more nuanced agricultural calendar, or they could have related to lunar cycles, helping to reconcile the moon's months with the sun's year. The Woodhenge was likely the stage for public ceremonies that united the practical need to know when to plant with the spiritual need to honor the cosmic order. Cahokia's timber circles remind us that the most profound observatories were not just for observing, but for gathering. They were dynamic, social spaces where the sky's patterns were translated directly into the community's schedule, where celestial knowledge was not locked in stone, but passed hand to hand and post to post in an enduring cycle of renewal. The wooden posts of Cahokia were a living calendar, but another culture would carve their knowledge directly into the heart of a mountain. On the misty hilltops of County Meath, the Loughcrew cairns whisper of an even older tradition. Known in legend as Sliab na Cailí, the Hill of the Witch, this sprawling complex of passage tombs predates even its famous neighbor, Newgrange, by centuries. Here, across several summits, dozens of stone cairns dot the landscape like silent, grassy domes. Their placement is not random. It forms a vast, integrated network, a celestial observatory built across an entire horizon. Within the largest of these, known as Cairn T, the Neolithic builders engineered a moment of pure magic tied to the equinoxes. The entrance passage is narrow and low, leading to a central cruciform chamber deep within the mound. On the mornings around the spring and autumn equinox, when day and night hang in perfect balance, a beam of sunrise light travels straight down this long, dark corridor. It does not merely flood the chamber with light, it performs. The beam strikes a backstone adorned with elaborate, swirling carvings known as petroglyphs. For a brief, glorious period, the light illuminates a specific series of symbols, most strikingly a radiant sun-like design, bringing the artwork to life in a sudden blaze of gold before retreating back down the passage. This was a deliberate, calibrated spectacle. The height and angle of the passage roof, the orientation of the entrance, every aspect was calculated to create this annual event. It transformed the tomb from a resting place into a theater of cosmic renewal. The illuminated sun, symbol at the moment of celestial balance, speaks to a profound symbolic language, connecting the cycle of the sun with ideas of return and regeneration. But the genius of Loughcrew extends beyond a single chamber. The scattering of cairns across multiple hilltops suggests a grander scheme. From one summit, an alignment might mark a solstice sunrise over a distant peak. From another, a tomb's entrance could frame the setting of a significant star. This was astronomy on a landscape scale, using the entire terrain as a three-dimensional measuring device. Different tombs likely tracked different celestial events, creating a coordinated, communal calendar that required movement across the sacred hills to fully comprehend. This network approach reveals a society thinking in interconnected terms, understanding that the sky's story could not be told from a single vantage point. They wove their knowledge into the very shape of the land, creating a permanent, interactive map of the heavens that demanded participation, pilgrimage, and shared witness to unfold its full meaning. The landscape-scale astronomy of Loughcrew required movement across sacred hills, but one city would integrate the cosmos into a single, overwhelming urban plan. Teotihuacan, the vast metropolis in the Valley of Mexico, was not merely built under the sky. It was designed as a mirror of it. Its centerpiece, the Pyramid of the Sun, is a mountain made by human hands. While its base is not perfectly aligned to the cardinal directions, this apparent deviation is itself a message. The western facade of the pyramid aligns precisely with the setting sun on two critical days each year, August 12th and April 29th. In the ancient Mesoamerican world, these dates framed the agricultural cycle, marking the beginning of the rainy season and the height of the growing period. For a city that sustained tens of thousands, this alignment was a direct architectural command, tying the life-giving sun to the rhythm of planting and harvest, and likely to the public ceremonies that ensured communal prosperity. This solar alignment, however, is just one piece of a much grander scheme. The entire city is laid out on a rigid grid with the central avenue, known as the Street of the Dead, and all major structures oriented 15.5 degrees east of true north. This was not a casual choice. Some researchers propose this axis points toward the setting point of the Pleiades star cluster, a culturally significant group of stars known as the Seven Sisters across many ancient traditions. Its heliacal setting, its disappearance into the sun's glare, may have marked a pivotal moment in their calendar. Others suggest the alignment is directed toward the sacred mountain of Cerro Gordo, a source of water and spiritual power. Whatever the primary target, the effect is staggering. Walking down the street of the dead, you are moving along a celestial axis, with every temple and platform positioned according to a cosmic blueprint. Teotihuacan was a living cosmic diagram. Its builders conceived of their urban space as a physical model of a sacred order, where the movements of heavenly bodies were encoded into the very streets people walked every day. This integration of astronomy, urban planning, and state power is profound. The ruling class did not just possess celestial knowledge, they embedded it into the immutable stone of the city itself, making their authority a natural, unarguable part of the universal order. The sheer scale of this ambition, turning an entire metropolis into an observatory, demonstrates a level of societal coordination and long-term vision that still inspires awe. It sets a precedent for the intricate celestial engineering that would define the later civilizations of Mesoamerica, where the sky was not just watched, but seamlessly woven into the fabric of civilization. Standing stones on a narrow isthmus between two lochs are lashed by Orkney's fierce winds, a circle holding its ground against the relentless sky. The Ring of Brodgar is not an isolated monument, but the dramatic centerpiece of a vast ceremonial landscape crafted over millennia. With a diameter of 104 meters, it is one of the largest and most perfect stone circles in Britain, originally composed of 60 towering megaliths. While time has claimed many of its stones, the remaining sentinels create a powerful geometry against the horizon, a geometry that scholars believe was carefully calibrated to the heavens. Unlike some sites with a single, dramatic solar alignment, Brodgar's purpose appears more complex, woven into the very fabric of the surrounding land. The circle itself is encircled by a massive, rock-cut ditch, creating a symbolic boundary between the ordinary world and a sacred space dedicated to the cycles of time and spirit. The key to understanding Brodgar lies not just within the ring, but in its relationship to everything around it. It is positioned with deliberate precision between two other major Neolithic monuments, the stones of Stenness and the enormous chambered tomb of Micho. This forms a ritual triangle across the isthmus. From the center of Brodgar, sightlines to specific stones or gaps in the circle align with the rising and setting of the moon at its most extreme northerly and southerly points during its long standstill cycle. Other alignments may have marked the solstice sun. This suggests the circle functioned as a grand observatory for tracking both the solar year and the more elusive 18.6-year lunar rhythm, integrating the two great celestial lights into one unified system. This astronomical function was inseparable from its social and spiritual role. The nearby tomb of Micho, itself aligned to the winter solstice sunset, tells us that remembrance of those who came before was a central concern. The Ring of Brodgar, then, was likely the stage for community gatherings that coincided with these celestial events. Imagine the scene as hundreds gathered within the henge at midwinter, witnessing the last light of the dying year fall across the landscape toward the ancestors' resting place at Micho. These were not separate activities. Science, ceremony, and memory were threads of the same cloth. By marking the sky's turning, the community was also marking its own place within a continuum that stretched from the distant past to the foreseeable future, honoring ancestors while ensuring the sun's promised return for the living. The Ring of Brodgar represents the Neolithic mind at its most expansive. It is architecture as cosmic model, a permanent clock built from quarried stone, set within a landscape that itself became a temple. It shows us a society capable of staggering collective effort, not for defense or storage, but for understanding. The circle provided a stable, shared reference point in a world governed by cycles of life, growth, and loss. It was where the community came together to reaffirm its bond under the watchful eye of the heavens, using the predictable movements of the sun and moon to impose order on the human experience, to find meaning in the turning of the seasons and the passing of generations. This profound synthesis of sky, stone, and society in the far north finds a startling echo in the dry heat of the American Southwest, where a different culture would paint its celestial knowledge not on the land, but directly onto the sheltered stone of canyon walls. Its round silhouette cuts a strange profile against the squared temples of Chichen Itza. El Caracol, the snail, earns its name from the spiral staircase winding inside its central tower, but its true purpose is written in the narrow slits piercing its walls. While the rest of the city celebrates the power of the feathered serpent with grand, angular pyramids, this building is a dedicated machine for watching the sky. Its circular, tiered design is a radical departure from Mayan architectural norms, a form dictated purely by function. Each of those slender windows is a precision sighting tube, carved through thick stone to frame specific points on the distant, flat horizon. From a darkened chamber within, an astronomer priest would have watched the slow dance of the planets against the black velvet of the night. The primary target, as at Uxmal, was Venus. One window aligns with the planet's northernmost setting point, another with its southernmost rising point. This allowed the Maya to track the full breadth of Venus's wanderings, mapping its complete 8-year cycle with stone and shadow. Another key alignment captures the setting sun on the summer solstice, anchoring this planetary tracker to the solar year, but the ambition likely went further. Some researchers suggest other apertures could have targeted Mars, Jupiter, or the Pleiades star cluster, integrating multiple celestial rhythms into a single, cohesive calendar system. This was not casual stargazing. It was a state-sponsored science of immense cultural weight. The Maya believed Venus, as the god Kukulkan in his celestial aspect, was a harbinger of both fortune and conflict. Its appearances and disappearances were woven into a complex web of prophecy that influenced the timing of warfare, royal coronations, and major ceremonies. The data collected from El Caracol's silent observations fed directly into the mechanics of their elaborate long-count calendar, a system capable of calculating dates across millions of years. The very existence of this specialized observatory tells us that celestial prediction was a cornerstone of Mayan governance. The ruling class required the most accurate possible forecasts to maintain their divine mandate, to know when the heavens favored action. By building El Caracol, they institutionalized the sky. They created a permanent, unmoving reference point where the cosmos could be measured, recorded, and interpreted for the benefit of the kingdom. This dedication reveals a layer of astronomical thought far beyond marking seasons. It shows a civilization engaged in long-term, mathematical modeling of the heavens, seeking to predict the future by deciphering the patterns of the gods themselves. In its round, purposeful solitude, El Caracol stands as a monument to the human mind's relentless drive to find order, not just in the simple rising of the sun, but in the complex, wandering paths of distant worlds. Rising from the flat Teutoburg forest like a petrified spine, the Externstein is a place that feels inherently sacred. 5 towering pillars of weathered sandstone, carved by ancient seas and glacial winds, stand in a dramatic line against the German sky. For thousands of years, this natural spectacle has drawn people seeking meaning, from prehistoric tribes to medieval monks. While its earliest uses are shrouded in mystery and modern controversy, one feature speaks clearly of an ancient dialogue with the sun. At the very top of the central pillar, reached by a precarious staircase carved into the living rock, sits a small, square chamber hewn by human hands. Its eastern wall is pierced by a simple, round window. On the morning of the summer solstice, from a specific position within this room, an observer witnesses a profound event. The rising sun, cresting the distant horizon, sends a sharp beam of light directly through that window. It strikes a niche carved into the opposite wall, a kind of stone altar, illuminating it in a sudden, brilliant disk. This alignment is too precise to be accidental. The chamber and its window are a minimal, elegant modification to a colossal natural feature. It represents the observatory in its most fundamental form, where human intention meets a ready-made celestial platform. The builders did not need to quarry and move megaliths across miles. They recognized a perfect natural vantage point and made a subtle, critical adjustment to harness the light. This blurs our definition of an observatory entirely. It suggests that for every monumental Stonehenge or Newgrange, there may have been hundreds, even thousands, of these adapted natural sites, places where a single boulder, a particular cave mouth, or a lone tree on a ridge served as a seasonal marker for a local community. Most of these sites have left no enduring trace beyond folklore, their knowledge passed down through practice and then lost. The Externstein survives because its scale is unforgettable. It stands as a powerful reminder that our map of prehistoric astronomy, built from the grand monuments that endured, is only a fragment of the true picture. The whole landscape was once alive with these silent, seasonal signals, a vast, informal network of timekeeping that connected daily life directly to the cosmos. This idea of a decentralized, almost organic celestial network prepares us for a final, stunning discovery, one that suggests an entire civilization might have woven this cosmic web into the most fundamental element of their survival, water itself. The stone circles of Europe stand as monuments to settled communities, but on the vast, rolling plains of North America, a different kind of celestial architecture took shape. The Moose Mountain Medicine Wheel in Saskatchewan rises from the high prairie, a perfect circle of limestone rocks laid out upon the earth. To the untrained eye, it may appear as a simple pattern, a mystery left on the grass. But every stone in its design carries intention, placed by ancestors of the indigenous peoples of the northern plains to create a permanent, open-air observatory. Its form is elegantly consistent, a central cairn connected by 28 radiating spokes to an outer ring, with additional cairns marking the rim. This was not art for its own sake, it was a functioning instrument built for a life in motion. The high elevation of the site provides an unobstructed view of the entire horizon dome, turning the sky itself into a readable dial. Key alignments between the outer cairns point unerringly to the summer solstice sunrise and sunset, anchoring the community to the solar year's pivotal moment of abundance. Yet the wheel's genius extends beyond the sun. Other carefully placed stones align with the heliacal risings of three brilliant stars, Aldebaran, Rigel, and Sirius. In the crisp air of the pre-dawn prairie, the first reappearance of Sirius, the dog star, was not just a beautiful sight, it was a critical signal. Its rising coincided with the peak of summer heat and likely marked the optimal time for the great buffalo hunts, the event upon which survival for the coming year depended. This integrated calendar blended solar, stellar, and lunar cycles into a single, elegant system. The wheel's design is a profound cosmological map. The central cairn represents the universe's axis, the place of connection. The radiating spokes are the paths of celestial bodies and spiritual forces, while the outer ring symbolizes the cyclical nature of all life and the encompassing horizon. This architecture reflects a world where there was no separation between the practical and the sacred, between watching the sky and living upon the earth. By gathering at this high place to witness a solstice sunrise or the rising of a key star, the community was doing more than checking a date. They were participating in a sacred order, realigning their lives with the universe's rhythm. The Moose Mountain Wheel and others like it were spiritual centers as much as they were practical tools. They provided a stable, eternal reference point for peoples whose lives followed the migratory herds, a permanent touchstone of knowledge and ceremony in an endless, changing landscape. In this seamless unity of purpose, we see a celestial philosophy that mirrors the very essence of the plains, vast, interconnected, and governed by cycles far greater than any single individual. Scattered across a high plateau in southern Armenia, Zorat's Kera feels like a field of silent, weathered sentinels. Often called Armenia's Stonehenge, this site presents a different kind of mystery, one not of perfect circles, but of purposeful disorder. Hundreds of upright basalt stones, some towering over 2 meters high, stand in a sprawling, seemingly chaotic array. Many of these stones bear a unique and telling feature, a clean, cylindrical hole drilled near their top. It is these peculiar holes that transform the site from a simple collection of megaliths into a potential astronomical instrument of profound sophistication. Some researchers propose that these perforated stones functioned as precise sighting devices for tracking the fixed stars. By peering through a hole in one stone, an observer could frame a specific, unchanging point of light in the night sky, using the stone itself as a stable reference against the slow turn of the heavens. Alignments have been identified pointing toward bright stars like Capella and Deneb, stars that do not wander like planets, but hold their positions with celestial constancy. This stellar focus represents a significant leap in astronomical thinking. While the sun and moon mark days, seasons, and tides, the fixed stars provide something else entirely, a permanent, unmoving map. For a culture situated on the highland crossroads of ancient trade routes, this knowledge would have been invaluable. Travelers and merchants moving over vast, unfamiliar distances could not rely on local landmarks. The night sky, however, was a universal chart. By knowing which star rose over a particular stone at a specific time of year, one could determine direction or even latitude, turning the entire plateau into a giant, open-air navigation school. The practice of using stars for wayfinding is a global story, from Polynesian voyagers reading the Pacific swell and stars to desert traders guided by the constellations across endless sands. Zorat's Kera suggests that this knowledge was not just carried in memory, but was physically encoded into the landscape, creating a permanent, communal reference that could be taught and verified. The debate around the site's primary purpose, whether funerary, ceremonial, or astronomical, is part of its intrigue. It likely served all these functions because for ancient minds, these concepts were intertwined. Honoring ancestors, conducting rituals, and reading the stars were all acts of connecting with a larger, eternal order. The drilled holes are a testament to technical skill and patient observation, a deliberate attempt to pin down the glittering chaos of the night into a reliable, stone-bound guide. This drive to use the eternal stars as a compass for human endeavor reveals a universal truth that our quest to find our way, both on the earth and within the cosmos, is a story written not just in the sun's daily journey, but in the silent, fixed light of a million distant suns. The fixed stars provided a celestial map for travelers, but another culture would build its calendar around the river that gave it life. The sheer scale of the Temple of Carnac in Egypt is overwhelming, a forest of colossal columns and towering obelisks built over 2,000 years by successive pharaohs. While its grandeur is distinctly pharaonic, the astronomical wisdom embedded in its stones may whisper of a far older tradition. The entire complex is meticulously oriented. Its main axis points precisely toward the winter solstice sunrise, the moment the sun begins its journey back north, bringing with it the promise of renewed life. This was no decorative choice, it was a profound symbolic alignment connecting the might of the god Amun-Ra, the sun god, with the very foundation of royal power. But where did this precise knowledge come from? Long before the first massive stone was carved for Carnac, the people of the Nile Valley were master observers. Their survival depended utterly on the river's annual flood, a deluge of water and fertile silt that arrived with stunning regularity. predicting this event was a matter of civilization's survival. For millennia, pre-dynastic communities watched the horizon from the riverbanks. They would have noted the sun's position against a distinctive palm tree or a notch in the distant cliffs at key times of the year, particularly around the solstices. They observed that the heliacal rising of the star Sirius, which they called Soptit, coincided almost perfectly with the Nile's inundation and the summer solstice. This celestial signal became the cornerstone of their world, marking their new year. This deep, accumulated knowledge of solar and stellar cycles, refined over countless generations of watching and recording, formed the bedrock upon which the later Egyptian solar calendar was built. That calendar, one of history's most accurate, was a direct tool of the state, used to schedule planting, harvest, and the vast labor projects that built the pyramids. When the pharaohs constructed Carnac, they were not inventing a new science. They were monumentalizing an ancient one. They took the Neolithic practice of horizon marking and translated it into architecture of unimaginable scale and permanence, etching the solstice alignment into a temple axis that would endure for ages. Carnac stands as a powerful bridge between worlds. It shows us how the patient, earth-bound sky watching of prehistoric farmers was inherited, formalized, and magnified by a complex civilization. The temple is the ultimate expression of that knowledge, a stone embodiment of a covenant between the people, their king, and the cosmos itself, a covenant first understood by ancestors who simply watched the sunrise over the Nile and learned to read its meaning. The story of Carnac's grand solar alignment began in a much humbler, more ancient place. Far to the south, deep within the Sahara's now bone-dry expanse, lies the final piece of our global puzzle, a site that pushes the origins of deliberate astronomy to a staggering new horizon. On the cracked, sun-baked earth of Nabta in southern Egypt, a small circle of stones sits in profound silence. This unassuming arrangement, built around 5000 BCE, is one of the oldest known astronomical devices on the planet, a testament to a forgotten chapter of human ingenuity. It was constructed not by pyramid builders, but by nomadic cattle-herding peoples during a fleeting window of time when the Sahara was a greener, more hospitable place. These communities faced a relentless challenge: the desperate need to predict the arrival of seasonal rains in an environment where water was life itself. Their survival depended on reading the sky with absolute precision, and the stones of Nabta are their enduring answer. The central circle is modest, but its alignments are anything but. Key stones within it are positioned to mark the sunrise on the summer solstice, the longest day of the year, and a critical pivot point in the seasonal cycle. Yet the site's ambition stretches further. A nearby alignment of larger, buried megaliths points toward the north, likely tracking the position of the star Sirius. Another line of stones targets the bright star Arcturus. This suggests these early herders were not just watching the sun, they were beginning to map the fixed stars, creating a rudimentary stellar calendar to supplement their solar observations. This integration of solar and stellar tracking, over 7,000 years ago, reveals a cosmological sophistication we rarely attribute to such early, mobile societies. Nabta shatters old assumptions about where and why complex astronomy began. It provides undeniable evidence that this profound intellectual pursuit developed independently in Africa, driven by the same universal human needs we have seen across continents: to find order, predict essential change, and secure survival against the elements. The circle itself is a masterpiece of minimalist design, a portable astronomy made permanent. The herders did not build towering monuments. They used what the land provided, carefully selecting and placing stones to create a reliable, communal reference point they could return to year after year. In this, we see the pure, foundational impulse behind every observatory we have explored, from the medicine wheels of the plains to the grand temples of the Maya. It was the first step in a journey that would lead humanity to map the cosmos, a journey that began not in palaces or cities, but in the dust under the vast desert sky, with a simple circle of stones waiting for the dawn. These stones scattered across the globe share a silent, common language. From the desert towers of Chankillo to the wooden rings of Cahokia, the same celestial moments commanded humanity's attention. The solstices and equinoxes, those four hinges of the solar year, were marked with relentless consistency. This was not a coincidence of design, but a convergence of need. Every agricultural society, regardless of its gods or customs, faced the same immutable deadline, the planting season. Knowing the exact day when the sun began its return at the winter solstice, or when it achieved perfect balance at the equinox, was the difference between a bountiful harvest and a season of hardship. They all looked to the same horizon, and they all found ways to make its message permanent, using a notch between hills, a line of standing stones, or a precisely angled doorway to catch the sun's pivotal light. This practical need to manage time and resources appears to be a universal spark, igniting a similar flame of inquiry in disconnected minds across the planet. Yet the tools they built reveal an even deeper shared instinct, the use of the horizon itself as a primary instrument. Whether it was the natural skyline of Kokino or the artificial one created by Chankillo's towers, the distant meeting of earth and sky served as a giant, stable dial. They understood that the sun and stars were moving, but the horizon was fixed. By establishing permanent markers, they could measure celestial motion against an unchanging terrestrial backdrop. This simple yet profound principle, turning the landscape into a measuring device, was discovered again and again. It speaks to a fundamental human logic, a way of making sense of vast, invisible cycles by anchoring them to the tangible world underfoot. The solution was so elegant that cultures separated by oceans and millennia arrived at it independently, a powerful testament to the shared architecture of the human mind when faced with the same magnificent puzzle. This celestial knowledge was never just a practical tool, it was always woven into the very fabric of belief and power. The observatory was never a standalone laboratory, it was the beating heart of the community. At Stonehenge and Mnajdra, the sun's light performed a sacred ritual within a temple. At Uxmal and Carnac, the precise alignment of a palace or a temple axis demonstrated a ruler's divine connection to the cosmos, sanctioning their authority as part of a celestial order. The astronomical calendar dictated not only when to plant crops, but when to hold ceremonies, when to go to war, and when to crown a king. Knowledge of the sky was a source of social cohesion, a shared story that reinforced cultural identity. It told the people who they were in relation to the universe, placing their individual lives within a grand, cyclical narrative of death and renewal, darkness and light. So what does this tapestry of stones tell us? It reveals that the drive to map the heavens is a fundamental human trait, as intrinsic as language or art. It arises whenever a society transitions from mere survival to a need for long-term planning, whenever it seeks to impose order on the chaos of time. These 20 observatories are not relics of primitive superstition. They are monuments to a profound and early scientific impulse, the desire to observe, record, predict, and understand. They show us that our ancestors were not passive inhabitants of their world. They were active participants in a cosmic dialogue, using stone and shadow to ask timeless questions about their place in the great turning of the sky. Their legacy is a reminder that looking up and wondering why is one of the oldest and most human things we do. From simple posts to intricate towers, these 20 sites sketch a map of human curiosity across millennia. They reveal our ancestors not as primitive people groping in the dark, but as pioneering astronomers who built a working knowledge of the cosmos into the very bones of the Earth. They were master timekeepers, reading the solar year with a precision that fed cities and guided empires. They were myth weavers, spinning stories of gods and heroes from the wandering paths of planets and the steady march of constellations. And they were brilliant engineers, turning landscapes into permanent instruments, encoding celestial patterns into stone so that their hard-won wisdom could whisper across the centuries to us. This shared heritage, found on every inhabited continent, speaks to something fundamental within us. It reminds us of our enduring connection to the sky, a connection that transcends culture, language, and epoch. The same drive that led a herder at Nabta Playa to mark a star's rising is the same drive that propels our most powerful telescopes today. It is the universal human quest to find our place in the grand scheme, to look up at the vast, silent expanse and insist on finding meaning, pattern, and order. These stone testimonies are proof that our story has always been written in dialogue with the heavens. We invite you to carry that legacy forward. The next time you step outside on a clear night, look up. See not just points of light, but the same stars that guided the builders of the Big Horn medicine wheel. Watch a sunrise and think of the moment it would have illuminated the altar at Machu Picchu or flashed down the passage at Newgrange. Which of these ancient wonders do you find most fascinating? Was it the stark practicality of Chankillo's towers, the sacred theater of Mnadra's temple light, or the patient, generational ambition of Stonehenge? Share your thoughts in the comments below. We would love to hear which story resonated most with you. If journeys into the depths of history and the mysteries of our shared past inspire you, consider subscribing for more explorations. The sky above us holds countless more stories, and the ground beneath our feet still guards secrets waiting to be read in the light of